Operations of set theory. In arithmetics, we use four operations such as addition, subtraction, multiplication, and division. These are the four operations mainly we use in arithmetics, that means normal calculation of mathematics. But in set theory, we don't have any of these calculations, any of these operations. Okay, here in set theory we have only two operations. They are union and intersection. So what are the operations of set theory? Which are union and intersection. These are the two operations we do perform in set theory. No addition, subtraction, multiplication or division. Okay. Union of sets. The union of two sets A and B. Let's take two sets A and B. Then the union of two sets A and B is the set of all elements that are members of A or members of B or members of both. Read once again. The union of two sets A and B is the set of all elements that are members of A or members of B or members of both. What do you mean by this? In a simple way, if we say about union, it's nothing but the combination of two sets. Combine two sets together and form a new set. That is considered as union of two sets. Now let's discuss what do you mean by each and every line of this definition. Consider two sets. A is set 1, 2, 3, 4, 5, 6 and B is set 1, 2, 3. Now when you find the union of these two sets, that means we have to combine these two sets together. These two sets to be joined together and form a new set. Okay, so when we find the union of these two sets, we get it as set. When you combine this all, what we get? Join all the elements together and form a new set. So 1 is the first element that repeat twice, so write only once. 2 is the second element that repeat twice. 3 is the third element. As they are repeating more than once, just write only once. Okay. Now 4, 5 and 6. So here we formed a new set which is the combination of A and B. We combined them together so that we formed a new set. But this set is same as the set A. That is meant by set of all elements that are the members of A. Because this sentence is given here because if A is the universal set, we discussed about universal set in the last class. As A is the universal set, A union B makes set A. If B is the universal set, A union B makes set B. If both are two different sets, for example, let's consider two sets. A is set 1, 2, 3, 4 and B is set 4, 5, 6, 7. Then the union of A and B. Union of A and B is set, combine these two sets, join these two sets together. We get set 1, 2, 3, 4 repeat twice, so write only once. 5, 6 and 7. It's very simple. Just join two sets. Even not only two sets, we can join 3 sets and no limitation for that. How many sets do you want to join? You can do that. Here I'm just taking as definition A and B. We can give any name for this one. We can give X, Y, C, D, any names, any alphabets can be given as names. Okay, you got what is meant by union? It's very simple. Okay, and now it's not an easy task for us to write always this union of A and B because it's time consuming. So for this union we require a symbolic notation. It is union. This is a notation we use for union. Just U sign. We have to read this one as union. Okay, this union sign is U. Just you have to write U. So if you want to make union of A and B, it's very simple. Just write A union B. A U B. We have to read that as A union B. A union B is set 1, 2, 3, 4, 5, 6, 7. Okay. Now let's discuss about the second operation of sets, which is intersection of sets. Remember the first operation is union of sets. Now it's intersection of sets. The intersection of two sets A and B is the set of all elements that are members of both A and B. Once again, the intersection of two sets A and B is the set of all elements that are members of both A and B. So what do you mean by this? In a simple way, we can say as intersection is a new set formed by taking all the common elements from two sets. Take the common elements from set A and set B and form a new set. You can call such a set as the intersection of two sets. Let's consider two sets. A is set 1, 2, 3, 4, 5, 6 and B is set 1, 3, 5. Now you know how to find the union of these two sets, as A union B is set of elements presented in either A or B or both. That means union is nothing but combination. Okay. But in case of intersection of two sets A and B is the set of elements which are common in A and B, which are present in both A and B. So what are the elements common you find here? Yes, 1 is a common element. So make it. 3 is there in both. 2 is not there here. Okay. Next 5. Now frame a set with the common elements. There we get a new set. Okay. This set is A intersection B. A intersection B. Always we cannot write intersection and don't think intersection sign is I, because union we used U. For union what we used? U. Okay, it doesn't mean that intersection is starting with I, so that is not the sign. Intersection is, this is a sign of union now. So intersection is nothing but just ultite. Just make the reverse of union. There we get intersection. So we can write this one as A intersection B. A intersection B. If P and Q are two sets, then P intersection Q. If X and Y are two sets, X intersection Y. If S, T, P are two sets, then S intersection T intersection P, if the operation is intersection. Next topic is subsets. Let's consider two sets A and B, where A is set of all quadrilaterals and B is set of all parallelograms. Okay, we have two sets, set A and set B. where A is set of all quadrilaterals and B is set of all parallelograms. Okay, and what are the quadrilaterals? What are quadrilaterals? Quadrilaterals are the geometrical figures which have four sides. Four-sided geometrical figures are called as quadrilateral. So what are the quadrilaterals we learned already? Yes, all rectangles, squares, rhombus, then parallelogram, then trapezium. Isn't it? They are main quadrilaterals. Okay, rectangles, squares, rhombus, parallelogram, trapezium, etc. Four-sided figure. Okay, now when we consider set A has these elements, and set B is set of all parallelograms. Okay, now when we consider set B is taken from set A, because set B is all parallelograms, that is here. Set B completely within set A. If you draw as a diagram, suppose this is set A, set B is within set A, nothing is outside. But if you take like this, set A, and if this is set B, if we consider this one as set B, we cannot say that set B is within set A. Set B is not completely within set A. So this is not the concept, this is the concept. If set B is a part of set A, simply think like that. Set B is a part of set A. Like for example, in our school, the Rajas International School, in that grade 9B or grade 10B is a part of Rajas International School, or grade 9B or 10B is within Rajas International School, isn't it? So that within part, that means grade 9B or 10B is considered as a subset of Rajas International School. Here we can say B is the subset of A. B is the subset of A. So it's very simple. It's a part of a set. So here what do we call for B? B is the subset of A. Then A is known as the superset. A is considered as the superset, and we use the same superset as universal set also. And this is the symbol we used for subset. Just suppose if A is a subset of B, then we write A is a subset of B. If P is a subset of Q, then we write P is a subset of Q. X is a subset of Y. Okay, so here you see, when you are seeing this symbol, it has one C shape and a line. This line stands for a subset is equal to the superset. A subset and supersets are equal. I'll show you one example. Let us consider a set, which is set A is equal to set 1, 2, 3. Let's try to make all the subsets of this. Okay. Now, if you take a part of the set, 1 is a part of set now. So we can say 1 is a subset of this set. Similarly, 2 is a subset. 3 is another subset. Can you make any more? Yes, set 1, 2. Set 1, 2 is within this set now. Set 2, 3. Set 1, 3. Is it over? No. We can frame two more subsets. Two more subsets. Its seventh one is nothing but the same set. Same set can be subset of a set itself. So we can say a set is a subset of itself. Okay, A can be written as A is a subset of A. A set is a subset of itself. Very important concept. Now we got only 7. We have one more. It is nothing but null set or empty set. An empty set is a subset of every set. So these two concepts you have to remember. When we consider the subsets, the first subset you can frame as empty set. An empty set is a subset of every set, and a set is a subset of itself. So that how many subsets are framed? 8 subsets. That means for a 3 element set we get 8 subsets. If there are 4 elements, you know how many elements can be framed? There will be 16 subsets will be there. If there are 4 elements in a set, there will be 16 subsets. 16 subsets. If there are 5 elements in a set, there will be 32 subsets. Okay. There are 6 elements in a set, there will be 64 subsets. It's very simple to identify. Just we have to use the formula 2 raised to n. 2 raised to n is the formula we use to find the number of subsets. If there are 10 elements in a set 1, 2, 3 up to 10, then there will be 2 raised to 10 subsets. That is 1024 subsets will be there. Okay, in those 1024 subsets, 2 subsets can be, one is null set and the second one is that set itself. Okay, so we already found the subsets of set 1, 2, 3 or set ABC or set XYZ as it has 3 elements. Let the elements be anything, that doesn't matter. There are 3 elements. The number of elements of set A is 3. Number of elements is normally known as cardinal number. Cardinal number. Okay. So number of elements of set A is 1, 2, 3. Then we get 8 subsets. Okay. Now suppose we are taking all these subsets except that set itself. We don't want that set as a subset. We don't want that set as a subset. Then how many subsets are formed? 7 subsets. Then these subsets are known as proper subsets. So how do we frame a proper subset? Yes, by eliminating that set. This set is also a subset here. Just eliminate it. That set is also a subset. 1, 2, 3 is also a subset. Just eliminate it. We get remaining subsets. They are known as proper subsets. That means the subset sign is this one. This is a symbol for subsets. Now we eliminated this one. Yes. Now we can call it as a proper subset. So subset is denoted with this one. Sorry, subset is with this one and proper subset is this side. We have to read it as subset of. Normally we use subset of. And sometimes if it is not a subset of, suppose B is set 3, 4. As A is set 1, 2, 3 and B is set 3, 4. Is B a subset of A? No, because there is an element 4 which is not in A. So here B is not a subset of A. So not a subset will be denoted with this sign. B is not a subset of A. Question. If universal set is set R, C, D, E, T, M, A, and H is set R, E, M, and J is set C, D. First question is to find H dash. That means H complement. Complement of H. You know what is H complement? What is H complement? It's nothing but mu minus H. Universal set minus H. Just recall the definition of complement. Complement of H is the set of elements which are presented in universal set but not in H. J complement, set of elements presented in universal set but not in J. That is mu minus H. So J complement is mu minus J. Universal set minus J. So we get this one as universal set is set R, C, D, E, T, F, A minus H, R, E, M. So when we cancel the similar elements, that means when we cancel H, we are cancelling H, that is H complement. H complement means not H, we don't want H, so we cancelled H. So what is remaining? We get C, D, T, A. That is H complement. So tell me what is J complement, which is mu minus J. Mu minus J. That is J should be cancelled. That means CD will be cancelled. So remaining we have R, E, T, M, A. R, E, T, M, A. That is J complement. Now H complement union J complement. H complement union J complement. That is set C, D, T, A union set R, E, T, M, A. You know, union is nothing but the joining of two sets. This set C, D, T repeats twice, A repeats twice, and M. That's the answer. Okay.